So very good morning, my dear students. We will be performing today the first experiment E1, experiment 1. The experiment name is verification of Ohm's law, the laws of series and parallel resistance. If we connect two resistors in series, so what will be the equivalent resistance? And if we connect the two resistors in parallel, what will be their equivalent resistance for that combination? So we want to verify the Ohm's law, and we want to get the equivalent resistance for series and parallel combination of the resistances. So actually, to perform the experiment, we need to have the apparatus, a power supply, a variable resistance, an ammeter, a voltmeter, and at least two unknown resistances. So if you see, this is our power supply. We'll be using here. This is a multimeter, so we can use this multimeter as a voltmeter. We can use this as an ammeter by setting that into that for using that as a voltmeter or as an ammeter. So we'll be using these two unknown resistances. So this is one, and I'm considering this is as R1, and this is another one. I'm considering this as R2. Okay, so we'll be connecting two resistors individually in the circuit with R1 and then R2. We'll be connecting them in series, back to back, one after another, and I'll be showing you how to connect them in series and then connecting them in parallel. Also, I will be showing you how to connect them in parallel combination. Okay, so if I show you, so what will be the circuit diagram we'll be using in this experiment? Okay, you see, so individually for a single resistance I'm using here in the circuit, so I'm connecting that. You see, so there is an EMF, a voltage supply, so I'll be showing you here. So I'm connecting a power supply. This is variable resistor. Okay, I'm connecting resistance R1, Rx, so it is R1, R2. So I can measure the voltage across R, and I can measure the current also. So one thing you should keep in mind, I must connect the voltmeter to measure the voltage across the resistor, across that in parallel, because voltmeter has high internal resistance. So no current will be flowing through that if I am using very low voltage, and so that the current will be flowing through the resistor. And I am connecting an ammeter in series because it has very low internal resistance, so the total current will be flowing through that, and we can record that the current. So I am connecting an individual resistor in that circuit, and I am measuring the voltage and current flow through that. And then I will be connecting the two resistors in series. You see, and there the two resistors have been connected in series. So R1 and R2 have been connected in series, and there is a power supply and a voltmeter and ammeter we can use here for measure the voltage and current. And similarly, I can connect them in parallel. So the two resistors have been connected in parallel combination, so we can measure the voltage, common voltage across that. I can measure the current. Okay, so when I have all the data of voltage and current for the three cases, individually for the resistors and individually for the series combination and parallel combination when I'm connecting them in the circuit, and theoretically we can find the equivalent resistance for series combination. As you know, so the sum of the individual resistances will give us the equivalent resistance. So we are using two resistors, so R1 and R2 will be the equivalent resistance. So when I am connecting them in parallel, so we can find, with the help of this equation, theoretically we can calculate the equivalent resistance is simply sum of the reciprocal of the individual resistances. Okay, so when I am getting the resistance, the voltage and current for each cases, so we can verify the Ohm's law. As we know, V equals to IR from the Ohm's law, so I equals to V by R. So we can find that V by I. So every time if it is constant, so we can verify that the Ohm's law from there. And also we can draw the graph by relating current and voltage and current intensity. So if we are getting a linear curve, so it is passing through the origin, so it can prove its proportional relation, and from there we can also find that constant resistance from the graph, and I'll be showing you later on the graph. Okay, so every time we'll be getting the voltage, we'll be getting the current. So I can also show you what will be the data we are going to collect. So this is the data table, you see. So first I will be collecting the data for voltage and current, individually connecting the resistors in the circuit. So first, if I connect this for R1, so I'll be measuring the voltage and current. So at least I'll be taking 5 observations for each resistor. So R1 I will be taking current and voltage, I will be taking the resistance, voltage and current for R2. And then for connecting the two resistors in series, in the same way I'll be taking the current and voltage every time, and when I'll be connecting the resistors in parallel, so I'll be also taking the voltage and current every time. Okay, so after getting the current and voltage, we can measure theoretically, we can measure from the experimental value, we can have R1 and R2. Okay, for series combination, for parallel combination, we can calculate simply with the help of the equation for series and parallel. I can calculate the equivalent resistance for series and parallel. Okay, and then we can also draw the graph for every individual cases. So first, after calculating the equivalent resistance for series and parallel, you see this is the equation we use for getting series resistance for parallel combination. Then from the collected data for the current and voltage, we can relate the current and voltage in a graph. So we will be getting a straight line passing through the origin. So if I connect voltage and current, as it is giving us a straight line passing through the origin, so it is verifying the Ohm's law. So from there we can find the slope of the line. So inverse of the slope actually gives us the resistance. And similarly for the resistor R2 and resistor having resistance R2, we can find also the slope from this equation, as this is y equals to mx graph. C is here 0. And for the series and parallel combination of the resistors, we can draw the two graphs also relating the voltage and current intensity. And in the same way, if we can find the slope, and the inverse of the slope will give us the resistance for both the series and parallel combinations. Okay, now I'm showing you how to measure the voltage and current across the individual resistors of different resistances. I'm showing you with the resistance R1. I'm connecting the first resistor, and this is the resistor I'm connecting. You see, I have connected the two ends of the resistor, and I'm connecting it. I'm connecting this with the power supply. You see, this is the power supply I'll be using. So I'll be regulating it. So you see, so what is the voltage I'm going to apply? So this time this is 0.5. Okay, if I fix it 0.5 volt, if I fix it 0.5 volt, 0.5 volt, 0.5 volt, 0. Okay, you see, I have set that for the voltage of 0.5 volt. You see here, this is 0.5 volt. So what is the current now I want to measure? So I'm connecting an ammeter. So this time this is a voltmeter, so I have regulated that. I have set that for using as an ammeter, so I have set accordingly. So this is an ammeter. It can measure maximum and current of 20 ampere current it can measure. So I'm connecting that in series, as I said. So I'm connecting here in series. So I'm connecting that in series. You see that ammeter is showing that value 0.26 ampere. So I'm recording that here in the data table. I'll be recording here. So for the resistance 0.5 and this is 0.21 ampere. So I have recorded the data. So for 0.5 volt, this is 0.21, and in the same way I'll be changing every time 0.5 volts, and I'll be taking the data. Okay, so for 1 volt, this is for 1, it is 0.61. For 1.5, okay, changing this into 1.5, that is 1.15 ampere. If I change that to, it is showing that it is 1.81. So please let it be settled down. So when it is becoming fixed, so don't take any fluctuated value. So the current is stable, you take that value. This is, so that was for 2, and this is 2.5, it is 2.61, and I'll be taking, this is for 3. So in this power supply we want to apply maximum 3 volt. We don't want to go beyond that because the resistance is not that high enough. So for that very high voltage, so it may be burned out. Okay, it may go it may be out of order, so please don't go into that. Okay, so I'm taking this 2.5 is 2.61. okay, then I'll be recording the voltage and current for another resistor with resistance R2. Okay, I'm connecting that in the same way, and I'm getting the data. So I have connected the second resistor with resistance R2, and I'm recording data. So for 0.5 volt, this time 0.41, and for 1 volt it is showing this is 0.90 ampere. For 1.5 volt, it is showing that 1.334. okay, then for 2, the current is 2.16 ampere. For 2.5 volt, it is showing that 3.03 ampere. Okay, so we have collected data for current and voltage for the individual resistors with resistances R1 and R2. So from this collected data R1 and R2, we can draw the graph, and from the linear relation between current and voltage we can verify the Ohm's law, and then from that we can also find the constant resistance, both unknown resistances R1 and R2. We can also calculate from there for further investigation of getting the equivalent resistances for connecting the resistor R1 and R2 in series and parallel. Okay, so I'm going to show you how can we connect the two resistors in series and parallel, and then how can we get the data for current and voltage. Okay, now I am showing you how to connect the two resistors in series. You see, there are two resistors I have connected. So this is one resistor, it has two ends, and this is another resistor, it has another end. So what I have connected, I am connecting them back to back. So the second end of the first one is being connected with the first end of the second one. So in that way I can connect them in series. Okay, so I am completing the correct connection. Okay. The free end of the first one I am connecting with the voltage source, so I am connecting with the voltage source, and the free end of the second one, that has been connected with the free end of the port of the power supply. Okay, and if I want to measure the voltage and current, okay, so voltage, what is the input voltage, I can show you from here. So I'm taking the input voltage from here. So what is the current, so I can measure in connecting that ammeter in series with in the circuit. Okay, so I'm connecting that in. Okay, now you can see the complete circuit diagram. So this resistor is connected in series with another resistor. Okay, they have been connected in series. You see, they have been connected back to back, and the free end of this resistor has been connected with the free end of this port with negative terminal, and another end that has been connected in series with an ammeter. Okay, so ammeter has been connected in series. You see, so I have connected this ammeter in series here, and it has been connected with the positive port of the power supply. Okay, now I'll be measuring the voltage and current from here. Okay, so I'm applying the voltage, and similar to that previous one, I'm applying the voltage 0.5 volt. Okay, we are measuring the current and voltage after connecting the two resistors in series. So you see, I have applied a voltage of 0.05, and we are measuring the current here, and I think you can see that clearly, 0.02 ampere, 0.02. Okay, then I'm changing that voltage, input voltage, to 1 volt, and it is showing that value 0.03. Okay, and for a voltage of 1.5, it is showing that 0.05. Okay, for an input voltage of 2 volt, the current is 0.06, and for 2.5 volt in this experiment we are applying the maximum voltage input voltage 2.5 volt, and the current is showing 0.8 ampere. Okay, so it was for series combination, and let us connect them for parallel combination, and in the same way we'll be getting the current and voltage. Okay, now we are connecting the two resistors in parallel. You see how we have connected them. So we have connected the two ends at two common points. Okay, so just like that, so you are standing, two friends are standing face to face, and you are holding your hands one another. So that is like that. So we have connected them in that way. Okay, now I am connecting that with that power supply. Okay, so I am connecting that at this point. Okay, and other end I can connect here in any resistor. If I connect that, that will be connected in a proper way. So I have connected that here in this case, because if I connect use more wires, so there will be some more voltage will be required. So for that I will be connecting that to this one end, and for measuring the current I am connecting an ammeter in series with that. So this is the way I can connect that, the ammeter. So ammeter I am connecting here in this case, so it will be showing the current. Okay, now I am applying the voltage, input voltage, and in the same way I will be measuring the current and voltage. Okay, fine. So this is 0.5 volt input voltage, and the current we are getting here, this 0. Okay, and the current is 0.07 ampere. So current is 0.07. Okay, so I'm setting this input voltage to 1. Okay, you see this time current is 0.15 ampere. So the fine tuning is very sensitive, so you need to set that very carefully. And for a voltage of 1.5 volt, it is 0.65 ampere. And again I am setting that to 2 volt input voltage, and the current is increasing, and the current is showing this time it is 0.77, and it is 7, 8. And the final reading for connecting the resistors in parallel for 2.5 volt, it is showing that 1.54 ampere. So we have completed collecting data for current and voltage for individually for the two resistors for verifying the Ohm's law, and for connecting two resistors in series and parallel, and to find their equivalent resistances. Okay, so as I have completed collecting data, I want to put the power off. Okay. Okay. Now I'm showing you how to complete the rest of the calculation. Okay, I'm showing you this. These are the data for the individual resistances. So I hope you can see them clearly. For R1, the current and voltage; for R2, current and voltage; and for series and parallel combination, the values of current and voltage for connecting them in series and parallel. So what you need to do next, you need to calculate the equivalent resistance for series with the help of these two equations. For series and parallel, theoretically you can calculate R1 and R2. So before that, you need to find out that value of unknown resistance R1 and R2. So how can you get that? If we draw the graph from the data we obtained from current and voltage for R1 and R2, if we draw a graph with current and voltage, relating current and voltage, you will be getting a straight line, y equals to mx graph. It will be passing through the origin, verifying the Kirchhoff's, verifying the Ohm's law. And as we know, v equals to IR. So if we find the slope of the line, that inverse of the slope will give us the resistance. So if I find that R1 will be 1 over m, and R2 will be 1 over this m. If I find the slope for the individual resistances, so we can find the resistances R1 and R2 from their slopes. Okay. Then we can get the equivalent resistances for them. Okay, so we can find the value of R1 and R2, finding the slope of the line. How can you get the slope? If we use the data and draw the graph using the Excel sheet, and if I put the values, so we can draw the graph. Okay, Excel graph we can draw, and from there we can find the slope of the line, and you will be getting inverse of the slope. They will be giving you R1 and R2, the resistances R1 and R2, and you can add them, so they will be the equivalent resistance for series and resistance, and you can put the value, calculated value here. You can put the value here, so you will be getting the inverse of the slope, that will be R1, inverse of the slope, that will be R2. So you can add them, R1 and R2, those will be the calculated value for equivalent resistance for series, and you can get the equivalent resistance using that equation for calculating the theoretical value of the equivalent resistance for parallel. And we also collected data for connecting series and parallel for the two resistors, and we got the value of voltage and current. And in the same way, we can draw the graph for the series and parallel combination relating current and voltage, and we can get also the slope here, and that's inverse of the slope can give us this RS 1 over M, and we can get RP, that is also 1 over M. So if we draw the graph relating the current and voltage, and from the slope if we can get, and then inverse of the slope will give us the equivalent resistance for series and also equivalent resistance for parallel, and put the values in the data table and make a comparison for that. So you are getting the calculated value from R1 and R2, and you are getting the experimental value from graph. So you can make also a comment on that. So what is the percentage error, you can also calculate them. And what will be the percentage error? So what is the theoretical value, considering these two values of resistances R1 and R2 we are getting. So we are getting, this is the theoretical value, this is the experimental value. So whatever the value is the higher value, so higher minus lower value divided by that theoretical value into 100, we can get this percentage error. So I am writing this, how can we calculate the percentage error? Percentage error, you can calculate that. So higher minus lower value over that actual value. So actual value is the theoretical value. So remember that. So you can calculate the percentage error with the help of this equation relation. So higher value minus lower value divided by actual value into 100 into 100. That will be the percentage error. Okay. So into 100, actual value is the theoretical value. Okay. So you can analyze the data, you can analyze the result, and in the discussion part, so you will be discussing the difficulties, the problems, the drawbacks you faced in this experiment, and you can also make a comment, how can you solve the problems, how can you get the remedy of these problems, and you can conclude that experiment, and you can take the initial from your instructor, and that rough copy, so you have performed the lab in the experiment in the lab, you will be attaching that with the fair copy when you will be submitting your final report. I think this is the way you will be performing an experiment. You will be collecting data, you will be drawing graph, you will be calculating for the calculated the value and result, and you will be analyzing the result in the discussion part and with the drawbacks. And that's it. Thank you.